Last week, we talked about solving systems of equations by graphing, so finding that point of intersection and looking at a graph. We also talked about finding the intersection point by substitution, for substituting in for one of the variables, either x or for y. And then there's actually one third and final way that we're going to talk about this week, how to solve for that point of intersection, because that's always our solution to a system of equations, is that point of intersection. And so the last way we're going to talk about to do that is elimination. So we're going to eliminate some variables. So elimination means exactly what you think it means. We want to eliminate one of the variables. So we either want to eliminate the x or we want to eliminate the y. And so eliminate means to completely get rid of it. We only want one variable left so we can solve for it. So we're going to start out with some equations, a system of equations that the variables will eliminate just by adding these two equations together. Okay, so this first one, we look and we see, oh look, this is 2y and this is negative 2y. And so if I add 2y plus negative 2y, that's going to make 0, and that's what we want. We want them to eliminate. So what I'm going to do is I'm going to rewrite these equations. X plus 2y equals 7, and then 3x minus 2y equals negative 3. And it's going to just be like a big addition problem. So we're just going to add them straight down like we would if we were adding just regular numbers. So we have 1x here plus 3x's is going to give us 4x. 2y plus negative 2y, those eliminate. That's what we want. We need those to go away. And then we have to add these as well. So 7 plus negative 3 is going to give us 4. Okay, now we have this equation, 4x equals 4, which is a one-step equation. So we're going to divide both sides by 4. We get x by itself, and we get that x is equal to 1. Okay, so again, we're solving a system though, so we want to make sure we get 1, comma, and we need the other variable. We need to solve for that y value. To do so, just like we did with substitution, we're going to plug it back into one of the equations. And then in this case, it doesn't matter which one. We can pick whatever we want. I think I'm going to go with the top one because there is no negatives in this top equation, and I like things that don't have negatives. So I know that this x is equal to 1, so I'm going to substitute in a 1 there and get that 1 plus 2y equals 7. Now I can solve this two-step equation by subtracting 1 from both sides and get 2y equals 6. Divide both sides by 2 and get y equals 3. So our final answer here is 1, 3, or 1, 3 is the point where those two lines would intersect. Okay, let's look at another one. So here we go. This time we have 3x plus y equals 20 and x plus y equals 12. Well, this time these don't necessarily cancel out. These y, there's not a positive and a negative, but I do see that there's just one y in both of these. So what I'm going to do is I'm going to multiply this bottom equation by negative 1 when I rewrite them so that those y's cancel out, because I need something to eliminate. And if I added it together right now, I would get y plus y is 2y. And that's not helpful. I want y plus negative y, which is going to give me 0. So I'm going to just rewrite the top equation. 3x plus y equals 20. And then I'm going to multiply all of the things in this equation. So all the terms are going to be multiplied by negative 1. So I will get negative 1x, negative 1y, and negative 12. Okay. Then I'm just going to add them like I did on that last one to get those y's to eliminate. So 3x plus negative 1x is 2x. Y plus negative 1y is 0. Those eliminate, and that's what I want. 20 plus negative 12 is 8. So I have 2x equals 8. And so the really nice thing is once the y's are eliminated, then I can just solve this one-step equation. If at this point you have two variables still, then something has gone wrong. Once you add these together, once you do this addition, you should only have one variable. You shouldn't have any y's if you have x's. And if you have x's, then you shouldn't have any y's. So you need to make sure you're eliminating something. So now I can divide by 2 and get x is equal to 4. Okay, so again, we still have to get what the y is equal to, because it's a system of equations. And this time I'm going to pick that second equation, x plus y equals 12, because that's pretty straightforward for me here. There's no coefficients, just less to multiply, so I'm going to put 4 in for x, and y is 12. Now I can subtract 4 from both sides, subtract 12 minus 4 is 8, so we get 4, 8 as our point of intersection of those two equations. Okay, we're going to do another one. If at any point you need to rewatch, the nice thing is since this is pre-recorded, you can rewatch, you can rewind, you can pause, you can go back, forward if you need to pause it to write things down, because all of these are in your notes that I gave you. All right. Perfect. Look, we have two variables that are the same number again right here, but they're both positive. We need one of them to be negative, so we're going to multiply this bottom equation by -1, or the top if you prefer. But I'm going to rewrite the top equation. And then I'm going to multiply everything. This 5x by -1, so it becomes negative. 3y becomes -3y, and 53 becomes -53. Now, again, at this point, I'm just going to turn it into a giant addition problem. 5x plus -5x, those eliminate, those cancel out. That is what we want to happen. 7y minus 3y, or 7y plus -3y, is 4y. And 77 plus -53 is 24. Okay, so again, at this point, I only have one variable, and that's what I want, is to eliminate a variable. And so in this case, I only have y's left, and that is exactly what I want to happen. Now I'm going to divide by 4 to figure out what y is, and I get y is equal to 6. So here we go. I know my y part of my point is 6. So then I'm going to plug that in to either one of the equations. And on this one, it doesn't really matter. Again, you can pick the top or the bottom. I'm just going to go with the top one. But I know that y is 6, so I'm going to rewrite this as 7 times 6. And then I get 5x plus 42 is 77. Now I can subtract 42 from both sides. These cancel, so I have 5x equals 77 minus 42 is 35. 35. Now I can divide by 5 on both sides and get that x is equal to 7. So our point here would be 7, 6. That is the point of intersection. Again, pause this at any point if you need to, so you can go back and rewatch or just get everything written down. All right. Oh, look at this one. This one's really nice and straightforward for us. We have a positive 2x and a negative 2x, and so we know those are going to eliminate when we add them together. So we don't have to multiply here because they're already going to eliminate, and that is what we're looking for, is for the two terms, the x terms, to eliminate each other. Okay, and on this one, they're already going to do that, so we don't have to multiply. So I just add these together. So 2x plus negative 2x, that goes away. Y plus y is 2y equals 4, because 3 plus 1 is 4. Now again, if I had an x here, that means I've done something wrong, but I don't, so I'm good, and I'm just going to divide by 2 on both sides and get y is equal to 2. So I know that the y part of my coordinate is 2. And I'm going to plug that back in to one of the equations, and I'm just going to go with the top one. So 2x plus y equals 3, but I know that y is 2. I'm going to subtract 2 from both sides. Get that. It goes away. 2 plus negative 2, so I just have 2x equals 1. Divide by 2 on both sides, and I get that x is equal to 1/2. And it's okay to get a half or leave it as 0.5, whatever you prefer. Okay. Let's do one more. So we have 2x plus 7y equals 5, and 2x plus 3y equals 9. This one, I would like to get this bottom one multiplied by -1 because it's positive 2x and positive 2x. And if I add positive 2x and positive 2x, they're not going to eliminate. I have to multiply it so that when I add those two together, they go away. We need them to be 0. We need the x's to eliminate. So one has to be positive and one has to be negative. And so to make that happen, I have to multiply one of the equations by -1. I'm choosing the bottom equation. You could choose the top and you should still end up with the correct answer. Oops, not plus. So then this becomes minus 3y and -9. Now I have 2x plus -2x, and that does eliminate, and that's what I want. 7y plus 3y is 4y, and then we have -4. 5 plus -9. Now I can divide both sides by 4 and get that y is equal to -1. Okay, so our y coordinate is going to be -1. I can plug it back in. I'm just going to use the top equation. And I'm going to plug in -1 where there's a y. Now I can solve this bad boy. I can add 7 to both sides. Get 2x equals 12. Divide both sides by 2 and get x equals 6. Okay, so our answer here is 6, -1. Okay, last one. This guy here. I'm actually going to ask you to pause the video and try this. I'll wait about 5 seconds and then I'll put the answers up. So make sure you pause it right now and try this on your own. Try this one on your own. Pause it, try it on your own, because I'm going to put the answers up in just a second here. Pause it, try it on your own. Okay, once you have tried this one, hopefully that's at this point, your answer should be 1812. So you should notice here that these y's actually will eliminate, the y and the plus y and the minus y. They will eliminate when you add them together. So then you get 2x equals 36. Divide both sides by 2 and get x equals 18. Plug that into either equation and solve for y, and you should get y equals 12. Okay? Please, please, please email me or jump back on Google Meets and let me know if you have questions. Otherwise, you have an assignment to work on. Also, feel free to pause this, go back, rewind it, watch any piece or part of this video again. But then go ahead and jump on and do that Delta Math assignment for tomorrow. And we will continue these notes on the backside, part 2, tomorrow. Have a great afternoon.